Welcome to Spring LIB.
We're told to suppose the refinery in exercise 51 is located 1 kilometer north of the river, and we're asked where the point P should be. So from exercise 51, we have this sort of setup where we have a refinery here, which is 1 kilometer north of the river. Then we have our river, which has a width of 2 kilometers, not to scale here on the picture. Then we have some point P on this north bank. And then we have a total of 6 kilometers away on the other shore. We have our tanks where we're storing material from the refinery. So we want to minimize the length of this path from the refinery to point P to the tanks. Now this distance from the refinery, horizontally from the refinery to the point P, we'll call this x. This is going to be in kilometers. So this length here is x, and therefore this length here on the other side is 6 minus x. So using this graph and Pythagorean theorem, the distance the pipe should cover, which I'll call d, is the square root of 1 plus x squared, or x squared plus 1, plus the square root of 6 minus x squared plus 2 squared, or 4. And the cost function is the sum of both distances, each multiplied by its cost per kilometer. So our cost function, c, is a function of x. Well, this is 400,000 times the square root of x squared plus 1 plus, and then the cost over the river, or under the river, is 800,000 per kilometer, times the square root of, expanding, this is x squared minus 12x plus 40. And minimum cost, we take the derivative of the cost function and set it equal to 0. So c prime of x, I'm not actually going to take the whole derivative here, but this simplifies to 400,000 x over the square root of x squared plus 1 plus 800,000 times x minus 6 over square root of x squared minus 12x plus 40. Now, if we set this equal to 0 to find the critical values, well, eventually we get x times the square root of x squared minus 12x plus 40 equals negative 2 times x minus 6 times the square root of x squared plus 4. If we square both sides, we get x squared times x squared minus 12x plus 40. And this is equal to 4 times x minus 6 squared times x squared plus 1. If you simplify this polynomial equation, you should get 3x to the fourth minus 36x cubed plus 108x squared minus 48x plus 144 equals 0. Now this is a quartic polynomial. You're probably going to have to use a solver or a graphing calculator to find the zeros. So we have two real zeros that we care about. X is about 7.1399. Notice, however, that our domain, well, in our figure, it's implicit that x can only be between 0 and 6, so we don't care about this 0. The other 0x that we find is 4.87637, which is inside our domain. Now we use the first derivative test. So if you choose a point to the left of this, say 4.8, you should find that C prime of 4.8 is approximately negative 20,000, which of course is less than 0. And that C prime of a number greater than this, let's say 4.9, is approximately 6,386, which is greater than 0. Now, since the first derivative changes from negative to positive, this means C changes from decreasing to increasing, so it follows that C has a minimum at x approximately equal to 4.87637. And therefore, the minimum cost is C at about 4.87637. Once again, if you use a calculator and you plug this in, this is approximately 3,826,358. I'm just going to leave it in this form. Obviously, there's more. And this is in dollars. And our answer is that point P is 4.876. Kilometers east of the refinery.